Scene script. Have you ever wondered what would happen if we could drill a hole straight through the Earth? Picture this, a tunnel, drilled right through our planet's core. This isn't your average tunnel though, it's a gravity tunnel. Now imagine dropping an object into this tunnel. Due to the Earth's gravitational pull, the object would start to accelerate, then decelerate as it nears the other side, repeating this cycle in a fascinating gravitational dance. Sounds intriguing, doesn't it? But let's dig a little deeper into this. To understand the challenges of drilling a hole through the Earth, we need to know what lies beneath our feet. Our planet is like an onion, with each layer having its own unique characteristics. Starting at the surface, we encounter the Earth's crust. This is where we live and build our homes. It's the thinnest layer, but don't be fooled by its fragility. It's solid, comprised of rocks and soil, and varies from 5 to 70 kilometers thick. Beneath the crust, we find the mantle, a layer of hot, semi-solid rock stretching about 2,900 kilometers deep. This isn't molten lava, but it's under so much pressure that it flows like a very thick liquid. Next, we reach the Earth's outer core. This layer is mostly composed of liquid iron and nickel and reaches temperatures hotter than the surface of the sun. Talk about a heat wave. Finally, at the heart of our planet, we find the inner core. Despite the extreme heat, it's solid due to the immense pressure. It's primarily iron and it's about the size of the moon. As we delve deeper into the Earth, the temperature and pressure rise exponentially. The deeper we go, the hotter and denser it gets. So it's not just a matter of digging a hole, we're talking about a journey through extreme conditions. Given the conditions inside the Earth, how feasible is it to drill a hole through it? Let's start by examining the technical challenges. One of the greatest hurdles we face is the extreme heat. The core of our planet is hotter than the surface of the sun, making it impossible for any known material to withstand such conditions without melting. And it's not just the heat. The immense pressure, thousands of times greater than at sea level, would crush even the most advanced drilling equipment we have today. Equally daunting is the molten core. This layer of liquid iron and nickel, churning and flowing, is not something you can simply drill through. It's more akin to trying to bore a hole through a turbulent ocean, but an ocean that's as hot as the sun. And let's not forget the sheer depth of the Earth. The deepest hole ever drilled by humans, the Kola super deep borehole in Russia, reached a staggering depth of about 7.5 miles. Impressive, yes, but it's less than 0.2% of the way to the Earth's center. The scale of the challenge is truly mind-boggling. So to answer our initial question, it seems that the task of drilling a hole through the center of the Earth is currently beyond the reach of our technology. As you can see, there are formidable challenges that make drilling a hole through the Earth currently impossible with our technology. But let's indulge in some science fiction for a moment. What would happen if we did manage to drill a hole through the Earth and dropped something in it? Well, assuming we've somehow overcome the enormous challenges of heat, pressure, and molten rock, let's consider the physics of the fall. If you dropped an object into the hole, it would initially accelerate rapidly due to gravity. However, as it approaches the center of the Earth, where gravitational forces from all directions balance out, the object would begin to decelerate. In this theoretical scenario, the object would reach maximum speed at the Earth's center, then start to slow down. It would continue to decelerate until it reached the surface on the other side of the Earth, at which point it would momentarily come to a stop before falling back down the hole due to gravity. This process would result in an oscillation, with the object bouncing back and forth, each time losing a little energy to air resistance, until it eventually comes to rest at the center of the Earth. But let's not forget, this is purely theoretical. In reality, the intense heat and pressure at the Earth's core, not to mention the molten magma, make this scenario impossible. So, while it's an interesting thought experiment, drilling a hole through the Earth remains firmly in the realm of science fiction, for now. In conclusion, the idea of drilling a hole through the Earth is a fascinating one. We've explored the Earth's interior, the drilling challenges, and a theoretical journey through this hole. While we may not be able to drill a hole through the Earth anytime soon, it's always exciting to ponder the possibilities. And who knows what the future of technology might bring?